Welcome back. And this is the final segment in our series of the homeostasis and body fluid. And we will talk finally about regulation of epithelial transport. So, epithelial transport is dynamic and regulated by neural, hormonal, and paracrine signals to meet the homeostatic demand. So, what is the importance of regulation? Why we are taking that? Well, the body must constantly adjust epithelial activity to maintain systemic balance under changing conditions. It ensures transport adapts to homeostatic needs, maintain fluid, electrolyte, and acid-base balance, adjust absorption, reabsorption, and secretion rates, and all these regulation achieved by neural, hormonal, and paracrine mechanisms. If there is any unbalance, there will be a disease. Let's say there is an unbalance in the ion transport or a water transport, hormonal transport, or nutrient transport. All these imbalances can cause diseases like increasing edema, increase diarrhea, increased blood pressure, kidney failure, and so on. So the neural regulation. So in the neural regulation, for example, in small example, enteric nervous system regulates intestinal and colonic transport. So there are local circuits regulate the gut, while the renal epithelia respond to the sympathetic signals to conserve water and electrolytes. So sympathetic nervous system modulates renal nephron transport. So these neuron inputs rapidly alter absorption and secretion. For example, the enteric nervous system of the gastrointestinal tract regulates solute and water transport by epithelial cells that line the intestines and colon. Again, the sympathetic nervous system regulates transport by epithelial cells in the renal nephron. Hormonal regulation. Aldosterone, which is produced from the adrenal cortex, increase sodium chloride reabsorption in the colon, nephron, and sweat ducts. Other hormones like antidiuretic hormone, AMP, also influence transport, and hormone provide systemic coordination of fluid and electrolyte balance. So aldosterone enhances aldosterone, which is a steroid hormone produced by the adrenal cortex. And this is an example of hormone that regulate the sodium chloride transport in the epithelial cells. We will talk more definitely about aldosterone in the renal system, and it will be introduced as a mechanic or how to function in um, the endocrine system. Finally, paracrine regulation. Well, locally produced signals act on nearby cells. That's how it happens. For example, histamine stimulates gastric parietal cells to secrete HCl. And we will understand the mechanism in the GI tract, how the acid produced, the chloric acid produced from the parietal cell in the gastric or the GI tract or in the stomach specifically. And this is part of the paracrine regulation or paracrine signaling. So I told you these are very important terminology I want you to understand, and this is the basic of our understanding in the future class. So cells that located near the epithelial cells of the stomach release the histamine, which then stimulates HCl secreting cells of the stomach to secrete the acid. Finally, mechanisms of cellular response. The short-term regulation alters transporter availability and activity, and there are long-term also requires new protein synthesis. So when acted on by a regulatory signal, the epithelial cell may respond in several different ways. So there is an endocytosis, which is retrieval of transporters. If we don't want for example, we don't want the sodium channel B on the top in the apical, a mechanism called endocytosis will retrieve the transporters down. And if you remember from previous slide, we talked about lysosomes, the symmetry of these molecules. So the transporter goes to the lysosomes, and it will be digested to the nutrient or the roots that to the amino acids and all the molecules, small molecules. Okay. Exocytosis, it's insertion form of vesicular pools. So if the protein carried from the endoplasmic reticulum by this mechanism and be staying here, or the proteins goes out, because we said, sorry, hormones are proteins, and we said endoplasmic reticulum produce the proteins. So the protein carry out in these vesicles and goes to the exocytosis in the blood extreme, channel gating, rapid changes in activity, and synthesis of transporters, slow long-term changes. So the key takeaways of this regulation in epithelial transport: epithelial cells adapt transport rates to systematic and local needs through multi-level regulation. So aldosterone and histamine are key examples. Regulation alters transporter number, activity, and synthesis, combines rapid and long-term mechanisms. So that's for everything. And thank you for your attention. And we will meet next time in the class to discuss all your inquiries. And I have some questions for you guys. So please listen to all segments of these videos, and we'll meet soon. Thank you so much for listening. Bye bye.